So in this video, what we're going to be doing is looking at how we can factorise quadratic expressions such as these. Now in the previous video, we looked at a scenario where we could actually factor out a common factor from all three terms first. Now we have 2, 5 and 2. They don't have any common factors apart from 1, so we can't really do anything with it. So that's out, I'm afraid. So what we've been dealing with is scenarios where the coefficient of x squared has been 1 when we had these three terms a few videos ago. Now it's going to be not 1, so in this case 2. How are we going to deal with it? Okay, so the plan of this video is this. I'm going to show you, first of all, how you can factorise this. What is the process? Then I'm going to try and justify the process. So I'm going to show you algebraically why that should work. And then we're going to have a go at a second example. Okay? And then in the next few videos, we're just going to go through lots of examples just so we can build our confidence up. So this is the process. Okay? Without explaining the why yet, but I will get there. So what we're going to do is we are going to first of all multiply the coefficient of x squared with the constant term at the end. So we're going to multiply the 2 by the 2. So 2 times 2 is 4. That's the first step. Now what you're trying to do is find two numbers that multiply together to make the 4 and add together to make the coefficient of x, 5. So it feels very similar to what we've done before, but we're not trying to find a number that multiplies to, two numbers that multiply together to make 2 and add together to make 5. It's multiply together to make 4 and add together to make 5. Okay? So you might spot that immediately. 4 and 1. Okay, so 4 and 1, 4 and 1. So what you're then going to do is we're going to rewrite this, but we're going to split the 5x up into 4x and 1 lot of x. Okay? Now, whether you decide to split this up as 4x plus 1x or 1x plus 4x, it doesn't matter. And I will show you both. Okay? So, we know it's going to be 4 and 1. And I will show you both at the same time. So, first of all, let's go with 4x plus 1x plus 2. Okay? So I've split the 5x up into those two terms, 4x and x. Okay? And what I'm saying is it is perfectly fine for you to do it the other way round, like so. Okay? So it doesn't matter on the order of those two. You might be going, well, clearly it doesn't, but the next stage might imply to you that it would. So that's the first thing. Step 2 is to then consider the expression, the 4-term expression that you have in 2 halves. I'm going to underline this half and I'm going to factorise it. I'm going to underline that half and I'm going to factorise it. Over here I'm going to underline this half and factorise it. And this half and factorise it. Okay? So, let's focus on this bit first. 2x squared plus 4x. Now, both terms have an x, and they both have a coefficient that's even, so you can pull out 2 as well. So 2x is common to both of those two terms. So I'm going to have 2x, open a bracket, and inside the bracket would have to be x plus 2. 2x times x makes the 2x squared, 2x times 2 makes the 4x. Now, for the x plus 2, x and 2 only have a common factor of 1. Okay? So I'm going to write that as 1 lot of x plus 2. Okay? Now this will feel a little weird. okay? But the key to it, and to know that you're doing it correctly, is that the two brackets that you get here should always be the same, okay? So they should both be x plus 2 in this case. So if you add x plus 2 and then x plus 3, you know you've gone wrong. So, if I do it on this side, 2x squared plus x, they both have a common factor of x. And that's it. So I'm going to pull x out. And then I would have 2x plus 1. X times 2x makes the 2x squared, x times 1 makes the x. And over here, for these terms, they both have a common factor of 2, so I'm going to factor that out. And I'd have 2x plus 1. 2 lots of 2x makes the 4x, 2 lots of 1 makes the 2. And spot how those two brackets are the same. Okay? So I know I'm on the right path, I'm on the right track. Okay, so the idea here is then that you've got two terms. You've got this term and this term. They both have a common factor of the x plus 2, because they both have that same bracket. So we can factor the x plus 2 out. And in our second bracket, well, I'd have to have x plus 2 times 2x and x plus 2 times 1. So the 2x plus 1 makes up the second bracket. So you'll have x plus 2 times 2x makes this term, x plus 2 times the 1 makes this term. And it is now factorised. Now if we do it the same over here, both two terms have 2x plus 1 as a common factor. The other bracket, well, it would be 2x plus 1 times x, and then 2x plus 1 times 2. And so I've got 2x plus 1 times x plus 2, which is identical to what I've got on the left-hand side. So what I've tried to show here is that that step where we split the 5x up into 4x and x, it doesn't matter if you write 4x plus x or x plus 4x. The next step will look different, but the final result will be the same. It doesn't matter which way you do it. Okay? So this is how we can factorise a quadratic like this without trying to do lots and lots of trial and error, which is what I'm trying to avoid here. It will appear a little strange, shall we say, okay? It will look a little strange. So what I'm going to do now is I'm going to try and justify it as to why we would do this. Okay? So I'm going to erase my second attempt there. And let's consider the end result. Okay, so once I've got an expression like this, my end result, I want it to factorise into a form. Let's write it as something x plus something times something x plus something. Okay, that would be the end result. Now, if I were to expand these brackets out, I would have ax times bx, which is abx squared. I'd have the ax times the q, so aqx. The p times the bx, so bpx. And then the p times the q, so p times q. Okay, and if I factorise those two terms in the middle, I can factor out the x, and I'd have aq plus bpx, and then I've got the plus the pq on the end. Okay, now this is looking potentially horrible, okay? Now, don't worry at the moment though, okay? Don't worry about it. So let's think back to what we did right at the beginning for this example. We multiplied the coefficient of x squared, by the constant term, 2. Okay? Now, if I did the same thing here, I'd be multiplying the AB by the PQ. So I'd multiply the AB by the PQ. And in our situation, it was 4. Okay? Now, the idea here is that I would like to know what the AQ and the BP are. What are those two numbers? And we know that those two numbers, the AQ, so think of it just as one number AQ, okay? Because I can rearrange this, can't I? I can rearrange this into AQ times BP. Okay? They would still be equal to 4. I'm just rearranging those 4 numbers that I'm multiplying together. So think of it as AQ and BP as 2 singular values. I want to know what they are so that I can then go, well, AQ plus BP will make, well, in our case, it was 5. So I'm looking for 2 numbers that multiply together to make 4, but add together to make the 5. So that's what we're doing at that first step. Now, we came up with the 4 and the 1. Okay? So, we came up with the 4 and the 1. And now imagine we don't have any of that. Okay, so imagine that that's not there now. And this was the quadratic that I was given. So what I'd then do is, having written it as 4 and 1, I can now expand that bracket out and say, well, I've got AQX plus BPX plus PQ. I'm going to look at these 2 pieces individually and factorise them. So for these 2 terms, they both have an A involved and they both have an X. So A and X are both common factors that I can factor out, and I will be left with BX plus Q. Okay? Then, over here, if I factorise this, they both have P involved, so I can factor P out, and I'd be left with BX plus Q. Now, these 2 terms here have BX plus Q as a common factor. BX plus Q is being multiplied by AX, and BX plus Q is being multiplied by P. And I now have it in my factorised form. So I get back to what I had up there. And this justifies why this method works, okay? Why we multiply the coefficient of x squared by the constant term, and then we're looking for 2 numbers that, in this case, we're multiplying together to make 4, but add together to make 5. That's why the process works. It's a little convoluted in the way that it looks there, because we've got the A, B, P, and Q. So it is quite tricky to follow, okay? But at the end of it, it's really about making sure that you can factorise an expression such as, here's another example, 2x squared plus 5x plus 3. So let's say we go back to an example like this and just see that process again, okay? So we're going to multiply the 2 by the 3, the coefficient of x squared by the constant term. So 2 times 3 is 6. So we're looking for 2 numbers that multiply together to make 6, but add together to make 5. So that is just the 2 and the 3, isn't it? Okay? And the next step is to split that 5x up into 2x and 3x. So 2x plus 3x plus the 3. Now, just so you can see, it doesn't matter which way round we do this. I'm going to do it 2 ways again. Okay, but I'm going to go through the full process first in this way, and then I'm going to do it that way. Okay, rather than go through them simultaneously. So you then split this up into 2 halves, and we're going to factorise each half one at a time. So 2x squared plus 2x, they both have a common factor of 2, and they both have a common factor of x. So factor out 2x, and we'll have x plus 1 inside the bracket. 2x times x makes the 2x squared, 2x times 1 makes the 2x. Then we're going to do the same over here. 3x and 3 both have a common factor of 3, and we're going to have x plus 1 inside the bracket. Now, because we've got the same bracket there and there, that means we know we're doing it right. So then in factorised form, we're going to have the x plus 1. Okay, we factor that out, and we have 2x plus 3 in the second bracket. And again, it doesn't matter which way around you write this. If you write 2x plus 3 times x plus 1, or x plus 1 times 2x plus 3, it doesn't matter. Right, let's do it the alternative way. So that would be splitting the 5x up into 3x plus 2x. So 3x plus 2x, like that. So look at the 2 halves. Now 2x squared and 3x both have a common factor of x, and we're going to have 2x plus 3 in the bracket. Over here we've just got 2x plus 3. The only common factor of 2x plus 3, 2x and 3 is 1, so 1 lot of 2x plus 3. So we'll have the 2x plus 3 as a bracket, and the other bracket is x plus 1. And we're done. Okay? So this is how we can factorise a quadratic of this form. It's a little bit more labour intensive than what we have been doing previously, but once you get the knack of it, it will become relatively quick. And I do say, in general, it's going to be quicker than just doing it by trial and error, okay? Because it's very easy to miss a possibility, because you can go through and start thinking, well, I know what one bracket has to have the 2x, one bracket has to have the x. And some of these examples, these initial examples, will be quite straightforward to do like that, and start to kind of think, well, it's got to be 3 and 1, so the 3's got to go there, the 1's got to go there. In some examples, that will be easy, okay? But in other examples, it won't be, because the factors will offer up lots and lots of possibilities, and it will be difficult to spot it. This way at least gives you an algebraic way of doing it that will work every time.